Hello everyone. Today I'm going to explain what is OSPF and how to configure OSPF. So OSPF is a dynamic routing protocol. So first of all, what is a protocol? Protocol is a set of rules and a routing protocol are used to facilitate the exchange of routing information between routers. Routing protocol is a set of processes, algorithms, and messages that are used to exchange routing information and populate the routing table with the routing protocol's choice of best paths. The purpose of dynamic routing protocol includes discovery of remote networks, maintaining up-to-date routing information, choosing the best path to the destination network, ability to find new best path if the current path is no longer available. So dynamic routing scenario. So if we are here and we are trying to reach to the other network, we need to know all the best routes to the network. So in order to configure this, we can manually configure a static routes between these routers one by one, or the other way is we can configure an OSPF process which can include all the routers in that is a dynamic protocol. So if our, as you can see, if our network is getting large, so it's really hard for us to configure static routes in our network. So dynamic routing scenario is best choice in larger networks. So what are the advantages? It is suitable in all topologies where multiple routers are required, generally independent of the network size. It automatically adapts topology to reroute the traffic if possible. So if there is any change in the topology, the OSPF will adapt to it and reroute the network to find the best path to the destination. So features of OSPF, it's classless, efficient, fast convergence, scalable and secure. OSPF creates three main databases. That's, that is adjacency database that creates its neighbor tables, link state database create the topology table, forwarding database creates the routing table. So here I have a single area OSPF. It is called area 0. It is used in smaller networks. So if router 1 trying to reach to router 3, it does not have the address of the R3. It has to go through the R2. So the R2 needs to know the both the networks in order to get to the R3. So we can configure OSPF on these routers to reach from R1 to R3. So here are some configuration commands that are used in OSPF. So first is process ID. It does not need to be same on another routers to establish adjacency. It is used to identify the process on local router. So you can make changes in the OSPF process. Next is router ID. It's a 32-bit value as an IPv4 address to router. It identify itself to the other routers using the router ID. The next the next most important command is network command. Network command is used to assign interfaces to an OSPF process. So all the directly connected interfaces of the routers should be included in the network so it can propagate these networks to the OSPF process. So other routers can reach to these networks using OSPF. So next is passive interface. Passive interface, as some networks you have local area networks, you do not want to send OSPF updates to those interfaces because it uses bandwidth and resources and increase security risk. So last we have verify commands. We can use show IP OSPF and show IP OSPF interface free. So this is a brief description what is OSPF. So now I'm going to tell you how to configure OSPF. So I have this topology. If I try to ping to reach PC2 from PC1, let's give it a ping. Command prompt 172.16.2.2. As you can see, it, it is saying destination host unreachable. So whenever we send a ping, PC1 will broadcast it to the S1 and S1 broadcast it to R1. This way R1 check its routing table and there's no entry for 172.16.2.2. We can configure a static or dynamic routing between these links so they can talk to each other. So I will configure OSPF on router 1 and router 2 to make them communicate. Let's do the R1 first. Go to CLI, enable the interface, go to configuration terminal. So the very first command is router OSPF 1. So you are in the configuration router mode. As you know, we have to include all the directly connected networks 1, 2 and 3. Let's start with 172. So go network 172.16.1.0. So it's asking OSPF wildcard bits. So add wildcard bits. It is reversal of the subnet mask. Next is area. So it is a single area OSPF. So it's area 0. So I have network 172.16.1.0 in the OSPF process. So the next network is 172.16.3.0. So this time it's /30, so it will be 3 area 0. So now I have this network and this network for the R1 OSPF process. Let's go to we have to configure, this is a LAN, so passive interface, always show port labels. So this is G00. Passive interface G00. So OSPF updates will not go to the LAN interface. So now go to R2 to CLI, enable configuration mode, router OSPF 1, network. So the first network will be 172.16.3.0 slash 33 area 0. So now you can see the process 1 on serial 000, that is this one. It is loading is done, so it is full now, it's working now. So the another one is this network 172.16.2.0 255 area 0. Passive interface G00, router ID 2.2.2. So it's saying reload or use clear IP OSPF process to clear IP OSPF process. Reset all, yes. So now we can check show IP OSPF. So as you can see, we have OSPF 1 with ID 222. So let's check show run if we have all the networks. You can see we have all the networks. So let's give a try to connect these two networks. So this is 172.16.2.2 ping 172.16.2.2. So it's working now. We are getting reply from this. So that's the single area OSPF configuration. That's it for the day. Thank you.